In places in the Tamala limestone, the karstification is quite extensive and forms caves that are big enough that you can walk into. And in this study, 4 years ago, we actually used these caves to observe the water movement from the surface down to the groundwater level, something that here we call deep infiltration. And it's quite useful to show you a picture or two from this paper, because you can see how the water is moving through the limestone by standing within the limestone in a cave. It gives you a unique opportunity of understanding the flow paths. I like to talk about it as using caves as observatories of the groundwater system. It's one of the few places you can go. You can walk underground into a rock and you can observe the water moving past you down to the groundwater table. So this image is of stalactites on the roof of part of the cave. It's actually a LiDAR image, it's not an actual photograph. So it's a laser image, which we then use to count up the number of stalactites on the roof and also work out how much water was moving through from the surface to the subsurface. Because from the quality of this image, you can actually see the water droplets on the end of the stalactites that are percolating water through them. What I really wanted to show you here was the distribution of the stalactites on the ceiling. And you can see that in many cases they're aligned. There's clusters together, so that's where there's going to be a fracture in the dune formation above the stalactites, and that suggests there's focus flow through fractures. But in other places, there's just a random scattering of stalactites, particularly in the background at the lower part of the picture. So here, we'll probably have flow predominantly through the pores, through the matrix. And then we have areas which have completely bare rock, no stalactites at all, which suggests that actually there are dry areas as well, where there's no water movement through that part of the unsaturated zone. So again, this highlights the complexities of water movement through carbonates and through limestones. But by standing in the caves and actually looking up at the water movement into them and through them, we can conceptualize what might be happening. And this figure shows you a conceptual model of the cave system and helps explain what can be done just through some limited observational data in terms of building a conceptual model which helps you understand your groundwater system. So in the upper half of this figure here, you can see that this is our conceptualization. We don't know if this is true or not. We just inferred this from our observations in the cave and our knowledge of the Tamala limestone being predominantly bedded dune sequences. And you can see in this upper part that we have arrows for fracture flow. We have evidence for fracture flow in the cave, and we've shown this is most likely to be along the bedding planes between the different dune features. We also know there's diffuse or porous flow through the pores, and so we've shown that as well as the wiggly arrows of water slowly percolating down through the carbonate system towards the caves. So we have a conceptual model there. We don't have any other types of geology. We just have a simple dune system. We have two types of flow. We have porous flow, we have a fracture flow, and that's our conceptual model for understanding water movement through the Tamala limestone. That should be relevant for Rottnest Island too. So in the assignment, you have data from 5 of the production wells, and they are the 5 that are circled with the big red circles shown here. And we have time series data for these bores. We went back every 3 months and we collected water samples for the water isotopic composition of these bores. We also have a very good long-term record of the water isotopic composition of rainfall. We have data both from the island that we collected, but also a very long-term record of the water isotopic composition from the mainland at Perth. This is an International Atomic Energy Association long-term monitoring record, which means we have data going back into the 1960s. So we have data for 2 types of water isotope. We have the stable water isotopes, that's oxygen and hydrogen, and we also have data for 1 radioactive water isotope, which is tritium, or 3H. So we have that for the input, the rainfall, we have that for the bores, and we have that over time. We can use that data in the lump parameter parameter model, the tracer LPM. And if you know the inputs and the outputs, the tracer LPM has a series of different lump parameter models that will try and optimize the model fit to work out an age, how long it's taken, the rainfall, to get to the groundwater at the time that we sampled it for every single occasion. And that's the assignment. And just so you can have a visualization of the bores on the island, this is one of the production bores. Very easy to sample because it's under pressure, and we just attach tubing, a hose to the system, and after a suitable amount of purging, we can collect some water samples for isotope analyses. And you can see there's a lot of standing around while you're waiting for the line to purge, as we are doing here in this photo. In contrast, this is one of the monitoring bores. So there's no pumps, it's not used for water supply, we have to provide our own pump and we have to purge the bore ourselves. And again, lots of standing around until this happens. In this photo, we're actually doing something. So the bore has been purged successfully, and you can see that the people handling the water samples are gloved up and taking very clean samples for isotope and geochemical analyses. And I'm the person without gloves who's doing the dirty work, keeping the bore pumps running and everything while everyone else is collecting the samples. So that's the context. You can see again the modern day environment, which is sand dunes that haven't lithified yet, and the bore fields are in the centre of the island and towards the coast, but even here at this monitoring bore location, you're still a long way away from the beach. So this is how far the Rutland Island Authority was concerned about possible saltwater ingress into the aquifer. So that's your tour of Rottnest Island. So hopefully you can conceptualize it. It's a karstified carbonate system made up of very young dunes, retaining its primary porosity with some fracture flow, probably along bedding planes, and very few other significant hydrogeological features that you'd need to worry about in terms of modelling.